Hello students, welcome back to my channel. Today we are going to discuss about the transportation problem. Transportation problem is related with the transport of the goods from the manufacturing plants to the warehouses, or from the warehouses to the wholesalers, from wholesalers to the retailers. So it's usually a kind of a decision related to the distribution of the goods and services from the industry or from the manufacturing plants to the market. Okay, so here, before we get into the calculation part of the transportation problem, let's understand the basic terminology of transportation problem. Okay, transportation problem, let's understand the basic terminology of transportation problem. Okay, first thing should be the feasible solution. Feasible solution means because we are discussing about the transportation of the goods from the manufacturing plants to the market or from the plants to the warehouses. So what we need here, we need the supply. You represent with the supply origins and represent with M, and demand to the destinations and represent with N. Why? Because transportation problem is one of the type of the LPP, linear programming problem. In linear programming problem, what we have the decision variables, right? And we have the constraints. Right? We have the constraints about the supply, about the demand, right? About the labor, and about the number of man days. Okay, man days, number of hours and man days we have. Transportation problem is one of the type of LPP problem where we have the decision variables, where we have the constraints, supply, demand, labor, man and hour days, right? So we have to convert, we can do this transportation problem with a simplex method also, because that takes a lot of iterations and lot of calculations part. So this is a simple way of doing the how to calculate the minimum transportation cost for any company. Okay, so these decision variables have to be converted into the form of a matrix, rows and columns, and even these constraints also have to be converted into the values where we can allocate those values, those variables we have to allocate in the cells. That cells will be formed when we convert this LPP problem in the form of a rows and the columns. Basically, the supply is a constraint and demand is also a constraint. So to convert the transportation problem into a matrix form, we need the supply and the demand. Okay, the second one, basic feasible solution, that consists of demand, supply. Demand must equal to the supply. Got clear? And also the rows and columns must satisfy this equation, M plus N minus 1. And the third one, optimal solution. Optimal solution is nothing but every company's objective is to find out the minimum transportation cost. Minimum transportation cost. This is the optimal solution. And fourth one, we have to check whether the given matrix is a balanced transportation one or not. Got clear? So basically the equation will be summation M A I is equal to summation N B I. Here X is equal to number of destinations, number of origins and number of destinations. M represents the origins and N represents the destinations. Okay, right? Here you can call this origins as a supply. Supply must equal to the demand. Okay, and fifth one is the unbalanced transportation one. Here take the same equation and you have to show that is equal to summation destinations bi x is equal to 1 and x is equal to 1. It means that here in the unbalanced transportation one, supply is not equal to demand. The sixth point is that matrix terminology. Okay, here the origins and destinations have to convert into rows and columns. And the last one is degeneracy. Degeneracy is related with the given matrix at all is not less than m plus n minus 1. So all these 7 points you have to remember before you start calculating the transportation problem. Okay students, so let's find out what are the methods with that we can calculate the transportation problem. So to find out the initial, basic, feasible solution, we have 3 methods. First one is northwest corner rule, and the second method is least cost method, and the third method is VAM method. VAM method is nothing but Vogel's approximation method. Okay, let's find out and calculate a problem, the initial, basic, feasible solution with the northwest corner rule. Okay students, so we have taken up and converted the decision variables and the constraints of demand and supply in the form of a matrix of 4 rows with the 6 columns. Okay, so here and we are doing with the method northwest corner rule. So give a directions to the matrix north, west and east and south. Okay, so here with this method we have to pick up the cells from the start. Okay, first row, first column will become the north cell and it has to go in a diagonal way, in this way. Okay, so first row, first column, second row, second column, third row, third column, fourth row, fourth column. Okay, now check the demand. Okay, so the demand to the first warehouse is 4, second warehouse is 4 and third warehouse is 6, fourth warehouse 2, fifth warehouse 4, and the plant consists of the supply of 5 units, second plant consists of 6 units, third plant consists of 2 units and fourth plant consists of 9 units. So compare demand with the supply and also supply with the demand and take the least number. If at all demand is least, pick this number of units and allocate in the first cell. And if the supply is less here, and pick this number of cell and allocate here in the third cell. So always go with the least number, compare the demand with the supply, supply with the demand. So our rule is that first row, first column, compare 4, demand 4 and with the supply number of units of 5 units of supply. So pick this 4 units from plant 1 and transport to the first warehouse and make this cancel it to 0 and minus 4 and 1 unit is left behind. Still it has to pick from the any of the plant and it has to transport to the any of the warehouse. Let's see later. First complete the diagonal process of northwest corner rule. Okay, so here and move on to the second row, second column. Compare the demand number of units and supply number of units and pick up the least number 4 units and allocate in this second row, second column and 4 minus 4 and lead to the 0. Okay, and 6 minus 4 and still 2 units have to be transported to the warehouses. Okay, and here move on to the third row, third column. Compare the demand number of units with the supply number of units. Here the number of supply of units, 2 units only available with the third plant, and pick up these 2 units and allocate in the third row, third column, third cell, and make it to 0, and 6 minus 2 is, and check, moving on to the next step of calculation part. Check the first column is ruled out, second column is also ruled out, and third row is ruled out. So what are the rows and columns of left behind? First row, second row, fourth row, and third column, fourth column, and fifth column. Let's see, can we allocate this 4 number of units in this cell and 2 number of units in this cell, and how to allocate this 4 number of units in these particular cells. Okay, let's see, can we pick up this 4 units from the 4th plant, can we transport to the 5th warehouse, and this becomes 0. 7 minus 4, it is 3. Okay, now pick up this 2 number of units again from the 4th plant and transport to the 6th warehouse, 2, and this also has been leads to the 0. So 3 minus 2 and 1, and here 4 units are still left, and 1 unit is here, 2 unit is here, and 1 unit is here. So can we allocate this particular, can we pick up the 2 units from plant 2, can we transport to the 3rd warehouse? Let's see, yes, and this 2 minus 2, this also has been to 0, and 1 unit is left here, and here, yeah, 2 minus, yeah, so we have picked 2 units from the plant 2 and we have transported to 3rd warehouse. It means 2 more units are left behind, 2 units here, 1 unit here, and 1 unit here. Let's see, can we pick up this 1 unit from the 4th plant and 1 unit from the 1st plant, and 2 again units from the 4th plant, can we transport to the warehouse 3 and warehouse 6. Okay, yes, so let's pick up this 1 unit from the plant 1 and transport to the 3rd warehouse. This also has been exhausted to 0, and pick up this 1 unit, and 1 unit we have picked from the 1st plant and transported to 3rd warehouse, and this leads to 1 unit is still left behind. Pick up the 1 unit from the 4th plant and transport to the 3rd warehouse, and this also exhausted to 0, and this also has been exhausted to 0. So did all the rows and columns have been satisfied and exhausted to 0? Yes. Check once again. Yeah, 4 4 0, 4 also 0, 4 to 4. Yeah, 2 plus 1 plus 2 3, 5, and 6 also have been got balanced here. 2 here got balanced, and let's check with the rows. First row 4 plus 1 5 also got 0, 4 plus 2 6 also got 0, 2 here also got 0, exhausted, and 2 plus 1 plus 2 3, 3 plus 4 7, 7 and 8 9, 8 9, and so total the 4th plant also have been, the 4th row also has been exhausted to 0. Now let's find out the minimum transportation cost. Take those only cells where the numbers have been allocated so that we can find out the minimum transportation cost. Minimum transportation cost is equal to 4 into 9 plus 1 into 9, 18, 11, 4, 8, 20. It must total to 132. This is the minimum transportation cost. This is how the way of calculating the matrix balanced transportation problem, and must satisfy the m plus n minus 1. Okay, got clear? If you have any queries or doubts, comment in the comment section. Please like, share and subscribe. Thank you.